Hi everyone. Have you heard of the bioeconomy? It's a concept that's gaining a lot of attention, seen as a promise for a new way to develop a sustainable economic system. Instead of relying on limited fossil fuels, the bioeconomy is based on renewable biological resources and the natural cycles of elements. This means using plants, animals, microorganisms and waste to produce food, energy, materials and much more. Many countries around the world are adopting strategies to stimulate their bioeconomy. But despite its growing importance, there's a big challenge. Measuring how much the bioeconomy contributes to our economies is difficult. Why? Partly because there isn't one single, clear and widely accepted definition of what the bioeconomy is. Different people and countries have different ideas. This study by Levy et al. Explores this challenge by looking at how the bioeconomy is defined and measured in various research papers. They found that researchers often focus on different aspects, leading to three main conceptual approaches. First, there's the biomass-based bioeconomy, or BMBB. This is the most common view, focusing on sectors that produce or use biomass as the primary input, like agriculture, livestock and forestry. Think of it as the economy built directly on biological raw materials. Studies often measure this type of bioeconomy, and it accounts for a large share in many national economies like Brazil, where it was 19.6% of GDP in 2019, or the EU, where it was 4.7% of GDP in 2017. The European Union strategy is closely aligned with this concept. Second, there's the Biotechnology-Based bioeconomy, or BTBB. This approach sees the bioeconomy as being driven by knowledge, innovation and technology, especially in life sciences and biotechnology. It's about using genetic engineering, synthetic biology and bioinformatics to create new solutions in health, agriculture, industry and more. The US perspective, for example, is more aligned with this concept. While the BTBB is growing rapidly, it's less frequently measured in studies compared to BMBB. Third, there's the Biosphere-Based bioeconomy, or BSBB. This is the broadest approach, emphasizing that the economy must operate within the limits of the biosphere and recognize the value of nature's contributions. It's about sustainability, ecological balance, and the essential services provided by ecosystems like clean air and water or biodiversity. This concept is often mentioned among citizens and consumers. The study argues that to truly understand the bioeconomy's full potential, we need to move towards a holistic bioeconomy concept. This means integrating all three approaches, recognizing that the biomass-based bioeconomy and biotechnology-based bioeconomy are subsystems within the larger biosphere-based bioeconomy system. Nature provides the essential basis for everything else. So, how do researchers measure these different aspects? They often use methods traditionally used for macroeconomic activities like input-output models, which look at how different sectors of the economy interact. They rely on data from official statistical databases and economic activity classification systems. The most frequently used indicators are value added, which contributes to GDP, employment, meaning the number of jobs, and greenhouse gas emissions. However, measuring the bioeconomy economically faces significant limitations. A major problem is data availability. Researchers often report incomplete, missing, aggregated or outdated data. While data for primary production or biomass-based bioeconomy is better, data for downstream activities and biomass content in products is harder to get. Measuring the biosphere-based bioeconomy is particularly challenging because many of nature's contributions don't have market prices. Assigning economic value to ecosystem services or the input of biological organisms, like microorganisms, is difficult. While methods like ecosystem service valuation exist, integrating them fully is complex. Similarly, measuring the biotechnology-based bioeconomy is hard because it's difficult to determine the proportional contribution of the biological organism versus the knowledge and technology applied to it. The lack of specific codes in classification systems for biotech activities is also a limitation related to the concept and data. The study concludes that current efforts only partially measure the bioeconomy's contributions. Most focus heavily on the biomass aspect, and few fully integrate the biotechnology or biosphere dimensions. To get a full picture, we need to pursue measuring the holistic bioeconomy. This requires adapting existing methods, developing new ones, finding better data, and creating specific indicators, especially for the biosphere-based bioeconomy. It also means economists need to work together with experts from other fields. Advances in technology and digitalization could help in collecting and analyzing the necessary data. Measuring the bioeconomy completely is a complex task, but recognizing the different concepts and challenges is the first step towards a more accurate assessment of its role in building a sustainable future. So, with these different ideas of the bioeconomy out there, how did the researchers in this study figure out how it's being measured? They followed a systematic process to answer that question. First, they dove deep into existing literature to define and understand the various concepts of the bioeconomy being used by other researchers and policymakers. They identified the three main partial concepts: the biomass-based bioeconomy, biotechnology-based bioeconomy, and biosphere-based bioeconomy, and proposed the idea of a holistic bioeconomy that brings them together. Next, they needed to find the research papers and documents that actually tried to measure the bioeconomy economically. They used a technique called snowballing. They started with a small group of known important papers on measuring the bioeconomy. Then, they looked at the reference lists within those papers, that's backward snowballing, and also looked at other papers that cited the starting papers. That's forward snowballing. They repeated this process in several rounds, like a snowball growing bigger, until they weren't finding many new relevant documents. This led them to a final set of 84 documents to analyze. They were careful to only include studies that actually measured economic aspects of the bioeconomy and described their measurement methods. With their collection of documents, they conducted a detailed content analysis. The researchers carefully read through each document manually. No automated text analysis here. As they read, they used software called QDA Miner to code or categorize specific sections of the text. They looked for how the authors in each document defined the bioeconomy concept, what methods they used for measurement, where they got their data, what indicators they calculated, like value added or employment, and importantly, what limitations or challenges they reported facing. For the bioeconomy concepts, they specifically looked for mentions of biomass-based bioeconomy, biotechnology-based bioeconomy, or biosphere-based bioeconomy. Finally, they used the software's tools to extract and analyze the results from this coding, looking at how frequently different codes appeared and how they appeared together, or co-occurrence. This systematic approach allowed them to map out the connections between the concepts researchers used and the practical ways they attempted to measure the bioeconomy, revealing the patterns and the limitations in current measurement efforts.